In the field of psychology, whether we're counseling, tweaking behavior, just observing, or even analyzing behavior, it's important for us to recognize the biological underpinnings of behavior. Recognizing that behavior is at least in part dictated by our biological makeup helps us avoid judging someone as a person for behaviors which can be traced back to biological discrepancies between that person and a neurotypical. Understanding the importance of the biological basis of behavior is absolutely critical for us applied behavior analysts to work as part of an interdisciplinary team which can address behavioral issues both at a behavioral and a biological level. So, in order to be the multidisciplinary, non-judgmental, well-informed practitioners I know we can be, we'll first familiarize ourselves with the limbic system. The limbic system helps us regulate emotions, process reward, helps us execute social processing. Parts of it are involved in automatic behaviors like heart rate, maintaining our blood pressure. It has much to do with sexual behavior, this whole world of social emotional processing with islands of autonomic function. We can trace all of this back to the limbic system. So let's dive into this system piece by piece and see how brain injuries to limbic regions can affect people's behavior. The first part of the limbic system we're going to cover is the amygdala. We know the amygdala has a lot to do with fear, anxiety, identifying threats. An excellent meta-analysis from 2009 shows that the amygdala is larger in size in people who've experienced severe trauma or people who have PTSD. This is a highly emotional, highly adaptable brain area and a core part of our limbic system. Now, pair the amygdala with the hippocampus and you get the neuroanatomical basis of classical fear-based conditioning. The amygdala and the hippocampus work together to associate certain contexts with aversive stimuli. Researchers Antoniadis and McDonald discovered in 2001 that damage to these two brain areas can debilitate people from associating an aversive stimulus with a neutral cue. This is rather pertinent information to this field. If a client suffers from lesions to either of these brain regions or the circuitry which connects the two, we should expect classical conditioning, especially punishment-based procedures, won't work as expected. Both of these brain areas serve other functions. The hippocampus in particular modulates our stress response hormonally. That is to say, it inhibits our stress hormone production. It regulates our stress. Damage to this brain area can explain why a client may be easy to rouse but hard to calm down. Now this green area here is meant to be the thalamus, which is a bulbous and diverse collection of neurons. It has such a diverse collection of subregions, it may just run us out of time if we decide to talk about all of the functions that it's relevant to. The thalamus has been known to regulate the sleep-wake cycle and alertness, but it does a lot more than that. A lot of motor information passes through the thalamus. Signals relevant to skeletal muscular movement, limbic movement, even eyeball movement rely on the thalamus as they make their way through the cerebrum. It can be quite easy to mistreat a person with thalamic damage if one is uninformed of the sufferer's state. We can perform a behavioral checkups using this 5-point scale, for example, to create a profile of the sufferer's motoric deficits so that anyone working with the client can know things like, oh, well, it says that the client has a 1/5 strength in their left arm. I'd better give them some full physical aid to pour that jug of water out. Or, hold on, this person is supposed to have level 5 strength in their legs. Why are they having trouble getting up? We better address this. Now, there are plenty more areas part of the limbic system, especially south of the thalamus. There are tons of important areas with some critical implications for client behavior, but with these 3 areas covered, we can say that with confidence that we now have at least some understanding of the limbic system. We know that irregularities in particular areas can impact the ability of our clients to engage with behavioral treatment, their ability to appropriately regulate their stressful behaviors, and their ability to execute basic physical behaviors, motoric commands, etc. Now that we have an understanding of the brain to an extent, we should be able to work more synergistically with members of our team who provide information on the biological irregularities present in our clients. If there is a client who's responding quite atypically to treatment, we should know that the problem may have a biological root, and we should be able to competently explore that avenue within our teams.